Although at the boundaries of the course, it would pay you to look very carefully at some of the sequence patterns we'll see. Please note, even though it looks like it's an exponential graph in the first place, this subtraction of a common difference precludes that. In a similar way, we're dropping down, but not an exponential decay. In the third instance, we're at a steady state. Moving on, and the asymptote business is not in the course. We'll find that by stealth, but you'll notice there'll be some scenarios that attain steady state scenarios as well. We're now going to look at the scenario where we've got an increase and a subtraction decrease as well. So once again, we've got a common ratio, but also a difference of minus 30. So working that through, if I'm to write a difference equation, the next term is equal to 1.20 times the previous term, take 30, and we must state where we're starting from. I've set this up on the calculator, so 1.2 times the previous term, take 30, starting at 120. And you can see the terms generated, so 120, first year 114, about 107, and so on. Now your calculator also has a graphing facility. Now I've set my graph up, so I'm just plotting. We don't want these points connected. So hit the graph there, we don't want that connection. So gplot, and you can see over the years how the numbers are decreasing, not an exponential decay though. Whilst it's a little bit hard to show on this scale graph, I've rounded my terms to whole numbers and I've sketched my graph like so. Now that's if we're increasing by 20% at the same time losing 30 people. Now if we've got a membership that increases by 30%, then we have to modify this equation in the following way. So it becomes 1.30 times t to the n, take 30, and t1 is 120. Now, as we're increasing by 30% times the previous year, taking 30, we have a different scenario presenting. I've lined them up together. Notice, please make sure when you enter you put in the bn term and not the an term, 100 to 126 to 133.8, etc. Now we can write that down and we could also graph it. So I'll just move that down a little bit. I'll have to adjust my scaling a little bit and remove the continuous, but you can see there a growth factor be considered. So I'll end up with a graph hooking upwards like so, as opposed to the dropping down that we had with the red graph in case A and B. Now for part E, rate of new membership if equilibrium is to be established. There's a couple of ways we can go about doing that. The easiest way, however, is to assume the equilibrium, which is Tn plus 1 is Tn is 120, and we can solve for that. So 120 is equal to R times 120, take 30. I'm running out of room for transposition, but when you do that, 150 over 120, which is 1.25 or 25% increase each year.